Is your screen shared?
Yes, sir.
Okay. Okay, thank you. Okay, let's start. So we are going to take the last topic of this chapter, that is batteries. Okay, batteries. Now see, there are two types of batteries or cell, you can say. Basically, what is battery? So group of cell is called battery. Now batteries are of two types. One is called primary battery and the second type is secondary battery. What is the difference between these two batteries? The battery which can be recharged after discharge, that is secondary cell or secondary battery, and the battery which cannot be recharged, that means after using you cannot use it, that is called primary battery. So I'm going to define this two. Cannot be reused again. Cannot be reused again. This is called primary cell. Primary cell. And the battery which can be reused, can be reusable, that is called secondary cell. That is called secondary cell. Now again, this primary cell, we need to we have a lot of example of primary cell, but we need to study about only two primary cell, that is Lect cell and the second one is mercury cell. The second one is mercury cell. And secondary cell, we have to study about three types of secondary cell. That is, the first is lead storage cell. Lead storage cell. The second we can take nickel cadmium cell. Nickel cadmium cell. And the third is fuel cell. So what we need to study here, there are two types of batteries or cell. The one is the first is primary cell and the second is secondary cell. Primary cell is the cell which cannot be reused again, and secondary cell is the cell which can be reusable or which can be reused. So there are some types of primary and secondary cell. You can read it, write it now. Please write it. Then one by one, we are going to see how these cells work and what is the equation of discharging and charging. Very easy.
Yes, sir. Finished.
Very good, Nafisa. Thank you. Fatima, Sneha, and Hamza, waiting for your reply. Please let me know when you are done with this. Very good. Sneha, are you done with this?
No, sir.
Thank you. Now see, first I'm going to take Lect cell. Lect cell. I'm going to draw a small diagram of Lect cell. First of all, you have to remember one thing. What is the voltage of these cells, which is very important. Sometimes in the questions it won't be given that the voltage of Lect cell or mercury cell is this much, so you have to remember it. So approximately voltage approximately it is 1.5 volt. Now I'm going to represent or draw a diagram of this. Please write with me. This is graphite and this is cathode. Now this is zinc, which acts as anode. Now see, the red one is basically paste of manganese dioxide. In this paste of manganese dioxide, ammonium chloride, NH4Cl plus ZnCl2, zinc chloride, and then carbon black. These are paste of this in this portion, the red one. Now this is connected with, like this is bulb. So this is the small representation black cell, in which you can see cathode, anode, and the paste of different compounds are there. So please write it. Very good, Sneha. Nafisa, Hamza, and Munir, Fatima Munir.
Yes, sir. Finish.
Very good. Now see, we have different types of reaction. At anode, we know that at anode there will be oxidation. So zinc will be converted into Zn plus 2 electron. Again, we can see there is oxidation at anode. We already studied that the oxidation will take place at anode. Then at cathode, there will be reduction. At cathode, reduction takes place. So which of these reduced? You can see MnO2. This is oxidized. That means 2 electron lost, lost by zinc. So these electrons, 2 electrons, will be gained at cathode. So MnO2, NH4 positive plus 2 electron will combine to form MnOOH plus NH3. So there is a question. Can anyone tell me the oxidation state of manganese here and oxidation state of manganese here? Please let me know. I'm waiting. Also the oxidation state of nitrogen here and here. Which one is getting reduced? Please let me know. Can anyone tell me the oxidation state of manganese on the left hand side? Please let me know if you don't have any idea about it. Nafisa, Sneha, Hamza, Fatima. Now see how we are going to calculate oxidation state. We have already studied in class 11 redox reaction. Now see we need to calculate the oxidation state of manganese. So I am taking it X. The oxidation, let the oxidation state of manganese be X plus. Now how many oxygen are there? 2. And what is the oxidation state of manganese? Generally it is -2. Is there any charge on this compound? No. So it will be equal to 0. Now this will be multiplied 2 into -2, that will be equal to -4 equals to 0. So X will be equal to +4. That means the oxidation state of manganese will be +4 here. Now going to calculate the oxidation state of manganese here. Now you can see, let the oxidation state of manganese will be X. What is the oxidation state of oxygen? That is -2. And here it is oxide, hydroxide. This is hydroxide. And you know there is a charge on hydroxide, OH negative. So the oxidation state of OH minus, the charge on OH minus will be -1. Is there any charge on this compound? No. So it will be equal to 0. Again, if you are going to solve it, it will be equal to x minus 3 equals to 0 and x is equal to +3. So oxidation state of manganese will be +3. So you can see there will be reduction of manganese. Manganese reduced from +4 to +3. Now I asked another question about the oxidation state of nitrogen. So let the oxidation state of nitrogen be X plus. How many hydrogen are there? 4. What is the oxidation state of hydrogen when nitrogen is there? So it will be +1. Will be equal to, now you can see there is positive charge, that means +1. It will be equal to +1. And if you are going to solve it, it will be equal to -3. Again, if you are going to solve this equation, so X plus 3 hydrogen are there and each have 1 plus 1 oxidation state will be equal to, there is no charge on the compound, so it will be equal to 0 and X will be equal to -3. So it's very easy. So which one is reduced? Manganese reduced. So questions will be asked like, what is the net cell reaction of Lac-Lanke cell? Or it can be asked like, what is the product formed at cathode or product formed at anode? The questions can be also asked like this. So please write it and let me know. Then I'm going to write the whole reaction. That means net cell reaction. What will be the net cell reaction? Hmm. Very good, Sneha. Nafisa, are you done with this?
No, sir, still right.
Okay, okay. Take your time.
Yes, sir. Finished.
Very good. Hamza, are you done with this? Good, Fatima. Now see, there is product that will combine to form a complex compound. This Zn plus 2 will combine with this NH3. Zn plus 2 combined with NH3 to form a different compound or complex compound. In the first book of last chapter, we will study about this, the complex compound. Basically, NH3 is a very good ligand, a strong ligand. So can it form a complex compound? So write this equation also. Then I'm going to write the net cell reaction. Net cell reaction, that means the reaction that is at cathode and anode have to add these two equations. You can write it on your own. Left will be added. Will please write this two equations. Let me know when you are done with this. Nafisa, Sneha.
Yes, sir.
Another primary cell, that is mercury cell. We saw that is we need to study mercury cell. We only learn what is the what is the reaction at cathode, what is the product form at cathode and anode, and what will be the net cell reaction. So basically here I'm first going to talk about voltage. So voltage approximately 1.35 volt. 1.35 volt. This is very important. Now at anode, what is present at anode and then at cathode, and which electrolyte is present as a paste? We will see Now you can see at anode, basically zinc amalgam is there, ZnHg, and at cathode, mercury side plus carbon, and here the electrolyte zinc oxide plus potassium hydroxide. Now we need to see what will be the, so where will be the oxidation, what will be the product at oxidation, sorry, at cathode. So at anode there is always oxidation. We have studied in this chapter that at anode there will be oxidation, at cathode there will be reduction. So you can see the oxidation will take place like this, ZHG plus OH, since you can see the medium is basic due to the presence of potassium hydroxide. Due to the presence of potassium hydroxide, so it reacts with it, and there it will be Zn plus 2 electron plus H2O. This will be the product. ZnO, 2 electrons, zinc will lose 2. Now again at cathode there will be reduction. So you see at how the reaction will happen. So plus 2 electron will give H2O. So this is the product at cathode, this product at anode. And net cell reaction, what will be what will be the net cell reaction? If you are going to add the cathode, the reaction at cathode and the reaction at anode, you will get the net cell reaction. So please write the net cell reaction also. So I'm going to write it here, net cell reaction. Electron and electron will be cancelled with each other. So net cell reaction will be ZnHg plus, you can see 2OH minus on the left hand side and 2OH minus on the right hand side, it will also be cancelled. Now plus HgO, and this 2 electrons and 2 electron will also be cancelled. So what it will give us here, H2O and H, this H2O and H2O will also be cancelled. So we will have only ZnO plus Hg. This is the net cell reaction. Apart from this, everything will be cancelled, like OH minus, H2 and electron, all will be cancelled with each other. Let me know when you are done with this. Please write it.
Yes, sir. Finish.
Okay. Very good. Hamza, are you done with this? Fatima? Now see, I'm going we are going to take secondary batteries. So in secondary batteries, there is lead storage battery the first. So I'm going to draw a diagram for lead storage battery. It's storage battery. These are all connected like this. Also, all are independent. Now there is a solution of concentrated H2SO4 in this. Mm. 38% H2SO4. This is cathode and this is anode. Wait a minute, it's hanging. This is anode. Anode is made up of lead and this is at cathode there is PbO. Please draw this diagram and let me know, then I am going to show you. The oxidation will be at anode and what is the product actually at anode, then cathode, and then the net cell reaction. And since it is a secondary cell, so there will be equation for charging as well as discharging. Very good, Sneha. Let me know everyone if you're done with this.
Yes, sir. Finish.
Hamza and Fatima. Very good. Now see, at anode we saw that only PV is there. So at anode there will be oxidation. So at anode PV is present. So PV will react with the solution part SO4 minus 2. SO4 minus 2. And it will form PbSO4. Since lead is in elemental form, so the oxidation state will be 0. And now it will form a compound with SO4. So PbSO4 and it will have oxidation state lead plus 2. and it will lose 2 electron. Who will lose 2 electron? Lead. Now we will see at anode. At anode, we saw that. Now we will see at cathode. Wait a minute, it's hanging a lot. At cathode, these 2 electrons will be gained by 2 electron will be added into. At cathode, there will be reduction. So we know that this is PbO2 at cathode will react with SO4 minus 2. Since SO4 minus 2 is also in the solution, SO4 minus 2 and H plus is also there. So it will combine to give PbSO4 plus 2H2. So these 2 electrons will be gained at cathode. There will be reduction. Now the net cell reaction. Net cell reaction means you are going to add these two equations at anode and at cathode, and you will get the net cell reaction. So net cell reaction, you can see Pb is there. Now you can see SO4 minus 2, PbO2 is also there. So I'm going to write PbO2. Now you can see on the left hand side SO4 minus 2 is there, SO4 minus 2 is there. So it will combine to form 2SO4 minus 2 and 4H plus on the left hand side also. So 4H plus. And on the right hand side, you can see PbSO4, it will combine to form 2PbSO4 and 2H2O and 2H2O. What about 2 electron? You know that these electrons are equal. 2 electrons on the left hand side and on the right hand side. These two will be cancelled. So this is the net cell reaction. And what is the reaction for discharging? Since this is the net cell reaction, the battery, the reaction or the equation for discharging will be same. So please write it, and then I'm going to separately write the equation for discharging as well as charging.
Yes, sir. Finish.
Very good, Nafisa. Hamza, are you done with this?
Yes, sir. Last one.
Oh. Now see the discharging equation. I'm going to write the equation for discharge. So discharging so equation will be same, only the difference will be Pb plus PbO2. Now you know that SO4 minus and H plus combine to form H2SO4. So it will form, together it will form 2H2SO4. These two combine to form 2H2SO4 and then 2PbSO4 and then 2H2O. This is the equation for discharge. So what will be the equation for charging? So equation for charging will be reverse of this. That means equation for charging will be 2PbSO4 plus 2H2O to give 2Pb plus PbO2 plus 2H2SO4 plus 2H2SO4. Please write it. Today there will be test.
Sir, finish.
Very good, Nafisa. Everyone done with this? Hamza, let me know when you are done with this. Okay. Take your time. Yeah. Okay. Okay. Very good, everyone. Now see, we have another type of secondary cell, that is nickel cadmium. That is nickel cadmium cell. So see what is at anode and cathode. We will see first it at anode. This is anode cadmium, and cathode NiOH, and the electrolyte is basically NaOH, that is sodium hydroxide. So there will be oxidation at anode and there will be reduction at cathode. And when you are going to add this reaction at anode and cathode, you will get net cell reaction. And that will also be the reaction for discharging. And if you are going to reverse that net cell reaction, that will be the reaction for charging. So it's very easy. So at anode, it will be cadmium react in the presence of base 2H minus, and it loses electrons. That means oxidation takes place. So here it will be CD whole twice plus 2 electrons. Again, if you are going to see at cathode there will be reduction. I'm going to turn off video because it's hanging a lot. So there will be gain of electron. So we can see 2 moles of NiOH react in the presence of water H2O and gains 2 electron to form NiOH whole twice plus 2OH minus. So basically, if you are going to check the oxidation state, this will have oxidation state plus 1 and this will have oxidation state. Wait a minute, not. Can anyone tell me the oxidation state of nickel? Yes, this will have plus 3 oxidation state and this will have plus 2 oxidation state. So you can see there will be a reduction. So what is the reaction for discharging and charging? Please write the reaction for charging and discharging. Let me know when you are done with this. So can anyone write the discharging? Please match the reaction for discharging. I'm going to write. So for reaction discharging, it will be cadmium plus 2 NiOH combined 2 to give cadmium hydroxide plus 2 NiOH whole twice. So this will be the equation for discharge. And you can easily write equation for right. If you are going reverse this equation, you will get the equation for discharge. Please write.
You're finished.
Everyone done with this? Very good. Thank you. Now the last can say field cell, field cell, also known as 2O2. So I'm going to draw a small diagram of this. This is an am I audible?
Yes, sir.
Okay, thank you. So when they combine, there will be H2O coming out from it. Now there will be oxidation and reduction. At anode, there will be oxidation. So we will see at anode, this is H2 combine with this base 4OH minus and lose some electrons. So it will lose 4 electrons. 4H2O, it will form 4H2O and it will form lose 4 electrons. So how does it possible? You can see hydrogen has an oxidation state 0 and here oxidation state hydrogen plus. One hydrogen will lose 1 electron. So 4 hydrogen will lose 4 electrons. Also, at cathode, there will be reduction. So how the reactions take place at cathode, you can see there is O and the combination of H2O combine and get 4 to form 4OH minus. So you can find the oxidation state of respective elements and you will get it easily. Which one is reduced? And net cell reaction 2H2 plus O2. See 2H2, this 4OH minus and 4OH minus will be cancelled. Again 4 electron and 4 electron will be cancelled. Now 2H2 combined with O2 to give, you can see 2H2O on the left hand side, 4H2O on the right hand side. So when it will move towards right side, so it will be subtracted from this, and this will be the net cell reaction. Please write. This will be the net cell reaction.
Yes, sir. Finish.
Finish, everyone. Please let me know. Answer me in chat box at least. No problem. Take your time, then let me know. And I'm going to conduct a test. There will be test every week. Hamza, are you done with this? Fatima? Are you done with this? Very good. Now I'm going to share a page, another screen. Please let me know. Everyone can see this page. Nafisa.
Yes, sir.
Okay. So I'm going to just take the question. Please write it in a proper way. Don't be in hurry, and make a PDF with your name and date and send it to the respective group of the coaching that you are in added. You are added in. Okay. So I'm going to give you question number 18, 19, 20, 21, and 22. So please start. I am here waiting for your reply. If you got any problem, let me know. You can take a screenshot or you can start solving the question. Okay.
Sir, we just have to write the answer. No need to question or.
No, you need to don't go on this. You just need to solve it and write the option, or you can also uh, do it subjective. Like see the questions and write your own solution with the answer. Okay.
Yes, sir.
Okay. Thank you.
Can you say the 27%?
Can you see the screen?
Yes, sir.
Okay. Second question. Okay, I'm going to show you the 22nd question. This is
Sir, can you show question number 19?
Hmm. This is question number 18 and 19. Yes. Okay. Can you send me in chat box because your voice is. I'm going to add your number. Okay. Is this okay, Sneha? Okay. Hamza, please write in chat box because your voice is too disturbed. I'm not able to hear you properly. Hamza, please write in chat box because I am not
Sir, I wrote
able
in
to.
chat.
Your voice is too disturbed.
Sir, I wrote in chat.
Okay, okay. Okay. I just gave you a number. They will just add you.
Sir, I'm not added yet.
Okay, no problem. You will be added soon. Then you will send it. Okay.
Sir, so where should I send?
Okay. Thank you.
Sir, where should I send?
Just keep it there. Make a PDF. You will be added soon. Then you will send it. Okay. Thank you.
Yeah.
Yes, Sneha.
Yeah, send in the WhatsApp.
Okay.
Thank you, sir.
Thank you. Hamza, I got your answer set.
Sir, I finished. Where should I send it?
Are you added in a group, Nafisa?
No,
Any
sir.
group of coaching?
For
I
chemistry,
think,
no.
okay. Then you have coaching's WhatsApp number, right?
Yes, sir.
Then send it to them and tell them to send me chemistry, sir. Okay. And they will be added to you in a group. They will add it.
Should I ask them to add me in the group?
Yes, yes, yes.
Because okay, sir.
Okay, thank you.
Sir, can I just take a picture of this, or should I scan it and put it in PDF?
If you can make it a PDF, then you should. Or if you want to take a picture, then take a picture and send it. Send it to
Okay,
the
sir.
WhatsApp. Okay, okay,
Okay,
thank
sir.
you.
Thank you.